In this video, we're going to take a look at the convergence of a Powr series, specifically finding the radius of convergence of a Powr series. There's two things that we're going to be wanting to find, and that is the radius of convergence and the interval of convergence, which I'll cover in the next video. So we determined in the previous video that there are three possibilities for Powr series convergence. We either can converge at the center only. And remember that all Powr series converge at the center, or over an interval around the center, plus or minus some value of a, or the third possibility being everywhere from positive infinity to negative infinity. And so Powr series will always converge at least at the center. To determine the radius of convergence, we're going to use the ratio test. And so remember that the ratio test means that we're going to be finding a limit. We want to find the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n. And we let this be equal to p. And if p is less than 1, it converges. And that's what we're going to be looking at. We don't need to look at anything else. We want to know where p is less than 1. So we're going to take this limit and we're going to set the limit so that it's less than 1, solve it to determine where it will converge. So let's do an example. Find the radius of convergence for this particular series. Okay, so we will let this be equal to a sub n. A sub n is going to be n to the fourth, x to the n, over 7 to the n. That means a to the n plus 1 is going to be n plus 1 to the fourth, x to the n plus 1, all over 7 to the n plus 1. So let's find the limit as n approaches infinity of the absolute value of n plus 1 to the fourth, x to the n plus 1, divided by 7 to the n plus 1, divided by a sub n, or multiplied by its reciprocal. Let's just go right to multiplying by the reciprocal. And that would look like this. So we learned in the previous chapter how to simplify these sort of things. There's no factorials in this, so it shouldn't be too bad. Let's break some of these up. N plus 1 to the fourth, we will just leave as n plus 1 to the fourth. X to the n plus 1, I'm going to break that up into x to the n times x to the first, and then times 7 to the n. Put them all over one big fraction. 7 to the n plus 1 is 7 to the n times 7 to the 1 times n to the ninth times x to the n. And so some of this is going to cancel out. Let's see, we have x to the n cancels with x to the n, 7 to the n cancels with 7 to the n. And so what we have is, that is n to the fourth right here, not the ninth. It looks like a 9. And so what we have is we have our x here, and then we have n to 1 plus 1 to the fourth over n to the fourth. So we could write that as the limit as n approaches infinity of x times n plus 1 to the fourth all over n to the fourth. Now we're taking the limit as n approaches infinity. So really x has nothing to do with this. Since x really has nothing to do with the limit, we can pull the limit out in front. It's like a constant when we're doing a limit, you can always bring the constant out front. So I'm going to bring the absolute value of x, because remember this is still within the absolute value sign, times the limit as n approaches infinity of the absolute value of n plus 1. And let's just put that over n, all raised to the 4th power. All right, well, n plus 1 divided by n becomes 1 plus 1 over n raised to the 4th power. Well, this then, as n becomes infinitely large, this whole quantity here just becomes 0. So we're left with 1 plus 0, or 1 to the 4th power is 1. So what we have here now is the absolute value of x times the limit of this, which is 1, which is just the absolute value of x. So remember that what we need to do now is we need to take the absolute value of x, which is really our p, and set it less than 1 to converge. So the absolute value of x is less than 1. And remembering a little bit about absolute value inequalities, we can rewrite this to be -1 is less than x, which is less than 1. So this actually is my interval of convergence from +1 to -1. On a number line, we have the center. Okay, and we didn't mention what the center was here. The center of this Powr series is 0. C is equal to 0 because right here we have x minus 0 to the n, which is really x to the n. And so remember, everything always centers at 0. All Powr series are converge at the center, which is 0. So on the number line, we have 0. Come on. We have 0. And now we have -1 over here and +1 over here. And so the radius of convergence from here to here, or from here to here, is 1. So the radius is 1. Now, how to find the interval of convergence? Well, the interval of convergence involves a little bit more work, and I'm going to talk about that in another video. But the interval is going to be from -1 to +1. We just don't know whether we include the -1 or the +1. In other words, our interval of convergence could either be from -1 to +1, not including the endpoints, or it could be from -1 to +1, including the endpoints. But for now, all we're looking for is the radius, which is r equals 1. All right, let's do one more